All right, so like I said, today is 2.2, which is trig functions of non-acute angles. The previous lesson for 2.1 was trig functions for acute angles, and that's where we talked about our 45-45-90 triangle, we talked about our 30-60-90 triangle, and just how we did all of these different functions. It's also where your book finally talked about SOHCAHTOA for the first time, even though I've already mentioned that back in chapter 1. So today we're going to use non-acute angles, which a non-acute angle is an obtuse angle. Yes, it could be a right angle, but we've already covered those, so that's not really what we're talking about. We're talking about these obtuse angles that are greater than 90 degrees. And so in order to talk about obtuse angles, we actually have to talk about a reference angle, which is indicated with the theta with the little prime mark up in the right. That's a reference angle indicator. This is an acute angle that is made by the terminal side of your angle theta and the x-axis. So I drew a couple of different references there of what those will look like if it's in quadrant 2, quadrant 3, and quadrant 4. So the reference angle is always going to be positive, and the reference angle is always going to be acute. And so basically when you're working with non-acute angles, what you're going to do is you're going to use a reference angle instead so that you have an acute angle, and then you're going to do all the stuff that you learned in 2.1 is what's going to happen. So that's kind of nice because it's not learning new stuff. The only new stuff you have to do is learn how to find the reference angle. And so if you're in quadrant 2, notice that the reference angle is indicated in green. It comes down over here, and it will always be found by dropping it down to the x-axis. So you're never going to find a reference angle in terms of your y-axis. It's always with your x-axis. If you're in quadrant 3, you're kind of thinking about this angle that's between your x-axis and your terminal side. And if you're in quadrant 4, you're thinking about your x-axis with this terminal side. So we're going to find the reference angle for the given thetas. That's the first style of problem you're going to encounter. Theta in A is 218 degrees. So if you are 218 degrees, which quadrant are you in? Huh? Yeah, you're in the third quadrant, right? So that means you're in quad 3. And if you're in quad 3 and you're making a reference angle, notice you're going to fall over here. It's going to look like this middle example. And so the easiest way to find your reference angle is to take theta minus 180 degrees. And that's going to give you your reference angle. Because you are making your reference angle based on the x-axis, which if you're in quadrant 3, that means you've gone 180 degrees so far. So if you take whatever your terminal side is for theta and you subtract that from the 180, that will tell you what this is. So you do 218 minus 180, and you get what? .38 degrees. So your reference angle then is 38 degrees. Now that's really nice when our theta is like between 90 and 360, but when theta looks like B, where it's 1,387 degrees, I don't know about you, but looking at that straight off the bat, I don't know what quadrant that lies in at all. So what we're going to have to do is first we're going to have to start by finding a coterminal angle. So if theta is greater than 60 degrees, you need to find a coterminal angle by dividing theta by 360. Now, you could think about it in terms of just subtracting 360 degrees over and over and over again until you get to something between 360 and 0. That's also another way to do it. If you do this division aspect, what it's going to do is it's going to tell you how many times you are actually subtracting that 360. It's really what's coming down to. So if I take 1387 and I divide that by 360, what do I get? 3.85. So what is 360 times 3? 1080. So I can take 1387 minus 1080, and that's going to give me 307. 307 lies between 360 and 0. So what quadrant does 307 lie in? Yep. Quadrant 4. So it's going to look like this last picture up here. So when it looks like that, what you can do is you can take 360 degrees minus your theta, and that's going to give you your reference theta, your reference angle. And there it's all shown in my notes as well. So if you have a very large coterminal angle that you're starting out with, you can either divide it by 360, and that tells you how many times you're subtracting it, and thus you subtract that total, or you can just start subtracting 360. You could take 1387 minus 360. Notice that doesn't lie between 0 and 360, so you're going to subtract again. And you keep subtracting until you get inside of that 0 to 360. The same thing's true if your theta was negative. Maybe it starts you off with a negative angle. What you're going to do then is you would add 360 until you get up into that positive range. Okay? Because you have to be able to figure out what quadrant you're lying in order to figure out what to do with your theta and how to find the reference angle. Are there questions on those two problems or how we found those reference angles? Okay. Here's another chunk of notes. It kind of just gives you a better picture of what you're going to do depending on which quadrant you're in. We kind of just figured it out from the first two examples that we did, because we did an example where our terminal side ended in quad 3, and we did one where our terminal side ended in quad 2. And we were kind of able to deduce then how to find our reference theta or reference angle. But this is a good little diagram to help show you what's happening, and I laid it out inside of the Cartesian coordinate system so that in quad 1, you're really not doing anything because your theta is automatically your reference theta or your reference angle, and that's because everything in there is already acute. But once you get out of quad 1 and you're in quad 2, then you are dealing with angles that are obtuse. And so your reference angle is going to be found by taking 180 minus theta. Notice on quad 2, it's 180 minus theta because your theta is going to be less than 180 degrees. And your reference angle always stays positive. Quad 3, though, you take your reference, or you take your original theta and you're going to subtract the 180. And that's because your regular angle, the angle you're starting with, is actually going to be greater than 180. And then quad 4 is just like we just found, where we are taking 360, because if you go all the way around your Cartesian coordinate system, you're going 360 degrees. So you're taking 360 minus your theta. ready to try one? Okay. What we're going to do is we're going to find the exact values of the trig functions for theta equal to 210 degrees. Your book and your homework uses that exact values terminology a lot, which what they're telling you there is they don't want you to give a decimal representation. They want you to leave it in fraction form. They want you to leave it with the square roots and things like that. So right now, we don't know how to find the trig functions of 210 degrees, but we do know how to find the trig functions of our acute angles. And so we have to do that reference angle. So first thing we need to ask is, what quadrant is 210 in? Yeah, it's down in the third quadrant. So if we're in the third quadrant, that means we're referencing this information right here. So to find our reference angle, we're doing theta minus 180 degrees. That's 210 minus 180.
Can you move the camera down?
Yes, I sure can. Thank you. That's okay. Kind of giving away the picture over there, but that's fine. So if you're in quad 3, then we're doing theta minus 180, so 210 minus 180 is 30 degrees. Hopefully, if you did watch the 2.1 video, you're like, okay, wait a second, we can do this. We had a whole section on 30, 60, 90 triangles back in 2.1, which is really, really nice. And so over here on the right-hand side, or on my actual paper in the notes, what I did was I just drew the regular 210 angle and showed you where that 30-degree reference angle is falling into place. Below that, I wrote the generic triangle for 30, 60, 90. And I know what the triangle for a 30, 60, 90 triangle looks like because we covered it in 2.1. Now, some of you might be like, well, how do we know that the side measures are these side lengths? Because we're starting to get into the area of where we're going to deal with our unit circle. And this is always going to be the measure of our 30, 60, 90 triangle. And I knew that if I'm in quadrant 3, my x and my y value are both negative. I know that. And so I know that the side lengths that are not the hypotenuse have to be negative. And then I know further from 2.1 that if I'm adjacent to my 30-degree angle, then that's where my radical 3 comes into play. And so I was able to draw this because of the stuff in 2.1, where we have in 2.1, we had our triangle drawn like this. Notice the side that's adjacent to my 30 degrees is my radical 3, which is what it is here. In this case, though, like I said, I knew it had to be negative because I was in quadrant 3. And so from there, I was able to finish drawing out my triangle based on my reference angle. And the really nice thing about the reference angles is that they're going to coincide with those acute angles that you already learned about in 2.1. So now when it's asking for me to find the 6 trig functions, I can do that because I know what my 6 trig functions are for 30 degrees. And maybe you don't have them memorized, and that's okay. You can reference them. You have that information. At the end of the 2.1 lecture, I guess I should leave it out. I gave a little table, and I told you I wasn't going to make you memorize it. I gave you this table. And I said you don't have to memorize it, but it is super helpful. And this is why it's super helpful. Because when you find these reference angles and you find that you're referencing the 30 degrees, if you have that memorized, then this problem goes like this. I mean, it's just copying down information. So it really does help you in the long run. But again, I'm not going to dictate and say that you do have to do it. Since I was asked to find the trig functions, I'm finding sine of 210. but that's the same thing as finding sine of 30. The only thing that you have to watch for is your sines. Okay? Because we're down in quadrant 3. So sine of 30 is the opposite over the hypotenuse, and so that's negative 1/2. The cosine is going to be adjacent over the hypotenuse. Tangent is going to be the opposite over the adjacent, but then we have to rationalize that denominator. And then for cosecant, secant, and cotangent, those are just the inverse angles of sine, cosine, and tangent. Should cosecant be negative? Yes, it should. It should have a negative there. Good catch. And I'm OCD enough, I can't draw it in with a pen, so I'll fix that later. Are there questions on how we found the reference angle or how we're using the reference angle in order to find the 6 trig functions for the sine or for 210? While I'm not going to work it out, there is an extra example in my notes, obviously very minimally, it's just the answers, for when theta is 225. When theta is 225, what you find is that your reference angle is 45 degrees. And so then instead of a 30, 60, 90 triangle, you're dealing with a 45, 45, 90, which is the other main acute triangle that we talked about in 2.1. And then you would do the exact same process. Do you have to draw the picture or the triangle every time? No, you don't. Because you'll start catching and seeing these. And honestly, when we get, what is it, a couple more sections? Is it in this section or is it in chapter 3? We get a little further in this class and we're going to talk about the unit circle. And then honestly, you're going to have a lot of this stuff memorized just because you're going to have used it so much. I will leave that up there. I'm just going to slide it up because there's another chunk of notes. Sorry, it's a little crooked. Finding trig functions for any non-quadrantal, I can't say that word, angle. So if theta is greater than 360 or theta is less than 0, that's what we're talking about. We're talking about angles that are going to be way too big, that don't actually fit on our Cartesian coordinate system, like the coterminal angles, or ones that are negative. So how do we deal with this? Well, first thing, you're going to find a coterminal angle by either subtracting or adding 360 until you do fall within that range. We kind of already did that with our 1387 problem that we had earlier. Once you do find that coterminal angle that lies between 0 and 360, then you're ready to find your reference angle. Then you can make sure you can find your trig functions for that reference angle. And the last step is just to make sure that your signs are correct. Because depending on which quadrant you're in, your signs are slightly different. And I made another Cartesian coordinate to show you which functions are positive in a given quadrant. Kind of like a quick reference sheet. So in quadrant 1, all of your trig functions are going to be positive. And hopefully that makes sense, because if you think about the sides of your triangle lying as x and y's, all x's and y's are positive in quadrant 1. For quadrant 2, your sine and your cosecants are positive. Everything else is negative. And hopefully that makes sense too, because your sine is going to deal with your y values, and your cosecant is the inverse of that. So that deals with your y values, which are positive. All of your other trig functions will have an x component in it. And that x is what's negative, thus making your other trig functions negative. When you're down in quadrant 3, tangent and cotangent are your positives. And that's because your x and your y's are negative here. So the only time you're going to get out a positive value is when you're dealing with both the x and the y at the same time, and that only happens with tangent and cotangent. And then quad 4 is going to be your cosine and your secant that are positive. That's because they deal with your x value, and your x value is positive. Everything else will have a y component, which will thus make it a negative. We're going to do a couple of examples of this, but I'll give you a moment to get that copied down first. What do you see? Oh, you're seeing the geese. Yeah, the whole field is full of them. They put those coyotes out there thinking they would deter the geese. They don't. And now all the coyotes are laying down on their sides, so I know that's real intimidating. I think they've kind of given up on keeping the geese off the field. Are we ready? Yeah. Okay. Let's do a couple. We're going to find cosine of negative 240 degrees, and then after that we'll find tangent of 675 degrees. So notice neither of these fall within that 0 to 360 range. So we're going to have to find coterminal angles first. And when you are negative, the way you find a coterminal angle is you're going to add 360 degrees. And when you do that, you get 120 degrees. Now, 120 is an obtuse angle, so we need to figure out a reference angle for it. What quadrant does 120 lie in? Yeah, it lies in quad 2. So if it lies in quad 2, your reference angle is going to be 180 degrees minus your theta. So in this case, it's 180 minus 120. And we find that our reference angle is 60. Now, we're finding cosine in quad 2. Based on what we just wrote down in our notes, is that going to be a positive value or a negative value? It's going to be negative. So this is where you have to be careful, because you need to put a negative cosine of 60 degrees. We don't just write cosine of 60 degrees because cosine of 60 degrees is going to give us a positive value. Because when we're finding these reference angles are always positive. But we need these to apply to the other quadrants, and so the values that we're getting out might not always be positive. So that's why we stick the negative out front, is to make sure that we remember this. Now, we do know our cosines is 60, or we can figure it out based on the notes from 2.1. 2.1, we had to find all the 6 trigonometric functions for 30, 60. So if I'm finding cosine of 60 is 1/2. But I have that negative out there, so cosine is negative 1/2. So if I know that table, or if I know that information, I can just reference it really quickly. If I don't know it, then either I'm going to have to compute it, or I'm going to have to draw a triangle, because I could have easily drawn, this is in quad 2, I could have drawn my triangle like this with my 60 degrees here, and I could have finished it out and found it that way. That is also okay. 1, 2, and square roots of 3, with this being a -1. Yes?
With the triangle that has a 30 and 60 degrees, does it matter if you switch the 30 and 60 degrees?
It doesn't, as long as you switch the sides. Because the sides have to stay the same. The adjacent side to your 60 degree is always going to be the 1. And the adjacent side to your 30 degree is always going to be that radical 3. So that is the important aspect of that. Is there questions on that one? Are we seeing how we're using coterminal angles and these reference angles in order to determine the value for these obtuse angles? We have to find a lot of different angles just to find one value. All right, let's try tangent of 675. So tangent of 675, this is greater than 0, or 360, excuse me. So I'm going to take 675 and I'm going to subtract 360 to try and find a coterminal angle. And it gives me 315. If I'm in angle 315, I live in quad what? 4. And if I live in quad 4, is my tangent positive or negative? Yeah. Tangent is negative. So in order to find my reference angle, I'm going to take 360 degrees minus my theta. Since tangent is negative, I'm going to take negative tangent of 45 degrees is what I'm using to find the tangent of 675. Tangent of 45 degrees, let me draw it, I guess, the way that it would be here. It should look like this. 1, -1, bless you. Square roots of 2. And this would be our 45, although it doesn't matter because both angles are 45. But TOA would be opposite over adjacent, which would be -1. Tangent for 45-degree angle is always 1, but then in this case it's negative because it lives in quad 4. Questions on how we did either of those? Okay. Let's do something a little bit different. We're going to evaluate an expression. We have cosine of 120 plus 2 sine squared of 60 minus tangent squared of 30. We've been learning all this stuff so that we can start dealing with expressions and equations using our trigonometric functions. And you're like, well, this seems like a lot. Well, it's not horrible because we know our sine of 60. We know our tangent of 30. We can get that information. So the only one we really have to deal with is this cosine of 120. Cosine of 120, that lies in quad 2. So our reference angle for that is going to be 180 minus the 120, which is 60 degrees. We actually just did this exact same thing on part A. We had cosine of 120. So it was negative cosine of 60, which is negative 1/2. So all of this information, cosine of 120 is actually negative 1/2. That's what we found. So now we need to ask, okay, well, what is sine of 60? Because that's this next bit over here. If you don't know, we can always write a triangle. Two and square roots of 3. Sine would be opposite over hypotenuse. So that's radical 3 over 2. And tangent of 30 then, 30 would be opposite over the adjacent, which is 1 over radical 3, which once you rationalize it is radical 3 over 3. So now we have the different values to plug in basically to this expression. I'm going to rewrite it so you can see exactly where everything is going. We found that cosine of 120 is negative 1/2 plus 2 times sine of 60. Well, sine of 60 is radical 3 over 2, and that's going to be squared. See how the squared is inside and connected to the sine? That's just how we write it with our trigonometric functions. Minus the tangent of 30 squared, which will be radical 3 over 3 squared. Now we have an algebraic expression that we just need to simplify. Minus 1/2 plus 2. If we square square root of 3 over 2, we're going to get 3/4. If we square square root of 3 over 3, we're going to get 3/9. One minus 3/9. So in the long run, we find that cosine of 120 plus 2 times sine squared of 60 minus tangent squared of 30 is equivalent to or equal to 2 over 3. So we can use all of this information that we've been gathering up this whole semester so far in order to actually simplify down these what look to be pretty complex expressions, but if you take it piece by piece, it's dealing with the 30, 60, 90 triangle and finding the cosine and the sine and the tangent of those things. Questions? Are we seeing where I got the information? Or are we completely lost? Or somewhere in the middle? I know it feels like Monday today, but it's not. Are you ready to take a couple more notes? We're almost done. Actually, we're going to do a couple more examples, I think. I'm getting my pages confused. 2. Yep. Am I good to move this? Okay. I'm going to flip it. We're going to use coterminal angles to find the values. Cosine of 780 degrees. That's obviously bigger than 360. So I'm going to take 780 degrees minus 360. That gives me 420. That's still bigger than 360. So I'm going to do it again. (60°). So a coterminal angle to 780 is just 60 degrees. So I'm going to do that. Cosine of 60. Cosine of 60 is 1/2. There's nothing else to do. Because the coterminal angle was the reference angle, we ended up in quadrant 1. So we don't have to worry about the negative signs or anything else like that. We didn't even have to find a reference angle. The coterminal angle fell, and it was already an acute angle, so we were done with that one. Cotangent of negative 405 degrees. Negative 405, we got to add 360 to that in hopes of getting up to a positive coterminal angle. We're not quite there, so then we'll take negative 45 plus the 360 to get us to 315 degrees. We've already dealt a little bit with 315 degrees because that was our coterminal angle for our tangent of 675 that we did just a few minutes ago. Right here. But this time we're finding cotangent. But that's okay because if tangent is negative in quad 4, cotangent is also negative in quad 4. And the reference angle for that would be theta, if you want me to write it all out again. 360 minus the theta, which is 360 minus 315, which is 45 degrees. Cotangent of 45 is 1, with that negative out front, gives us a negative 1 value. So those are really pretty much just like the ones we did before our expression one. But I wanted to do a couple extra examples of that. Now we're going to find theta given an interval and function value. So really, these last few problems are just worded slightly differently, but we're still kind of doing the exact same process. But I wanted to make sure and give you an example of everything you're going to see on your homework or on your quizzes. And I wanted to do that in such a way that you are seeing it even in the same wording. So for this example, what they're telling us is that they want us to find all the values of theta if theta is in the interval from 0 to 360. If you remember your interval notation, that means you could equal 0, but you can't equal 360. And cosine of theta is negative square roots of 2 over 2. And somehow we're going to have to figure out what theta is based on this little bit of information. But luckily you actually are given quite a bit of information, even if it doesn't seem like it. The first bit of information is to look at your cosine. It's negative. What quadrants is cosine negative? Yeah, it's negative in 2 and in 3. Okay, so we know this. And since I'm kind of walking you through my logic of how we've solved these. Since cosine is equal to negative radical 2 over 2, are we dealing with a 30, 60, 90 triangle or a 45, 45, 90 triangle? Yeah, so that means our reference angle is 45 degrees. So it said find all the values of theta. Okay, so what does that mean? Well, what we found was theta could lie in quadrant 2 or theta could lie in quadrant 3. Bless you. So we're going to find 2 different values for theta, okay? Because we have to find the value when it lies in quad 2 and when it lies in quad 3. So I'm going to write quad 2. And when we lie in quad 2, our reference angle equals 180 degrees minus theta. Well, we said our reference angle was 45 degrees. So we're doing the algebra to figure out that theta is 135 degrees if it lives in quad 2. Now, based on the stipulations that this problem gives us, though, we could have a theta that lives in quad 3. So we do it the exact same process for quad 3. Where our reference angle equals theta minus 180 degrees. Bless you. So theta could be 225. The key thing here is it says, bless you, all the values. So you could find multiple values depending on the stipulations that they give us. We know that theta has to be between 0 and 360, and we know the cosine of theta is negative radical 2 over 2. With those stipulations, there's 2 different values that could fit. So don't be afraid of getting more than one value when it comes to these problems. Are there questions at all? I know that was quite a lot.